Hi, everyone. This is Rich Berliner from Digital Locations, and I'm here today with Paul Sutton from the University of Denver. And Paul, it's great to have you on our podcast today, and thank you for joining me. I've been studying your background. You got an incredible background in basically using satellite data, terrestrial satellite data, to understand what's going on and use that for a number of different things. So can you give us a little background on you and what you're doing and how this maybe fits in with what we at Digital Locations are working on with high-speed internet to your mobile phone?
Yeah, thanks, Rich. It's a pleasure to be here. I started out in grad school in the mid-1990s, and I was a population activist thinking that the world's environmental problems were driven by overpopulation. I've come to believe it's more an empowerment of women and capitalism problem. I won't go down that rabbit hole. But while I was in grad school, I saw a photo of the Earth at night, similar to what's behind you in your background. And I was like, wow, those images of the Earth at night obtained from nighttime satellite imagery are really cool. And I was like, wow, I wonder if they're using satellite imagery to map population distributions. I studied demography, and I contacted the people that were running the archives for DMSP, which was Chris Elvidge, the Defense Meteorological Satellite Program at the time out of Boulder, and he was kind enough to let me use his data, and I used it to map population distribution. I expected someone would have already done that, but nobody had, and I was combining GIS, geographic information systems, with remote sensing, satellite image processing, merging satellite imagery with census data to see how good nighttime satellite imagery could be used as a way to map population distribution and population density. So that was the first exploration. But then I realized that nighttime satellite imagery could be used for lots of things. You could map energy consumption. You could map carbon dioxide emissions. You could map money. You could use it in addition with other sources of information to make estimates of the size of the informal economy. You could measure carbon footprints, ecological footprints, distribution of wealth, Gini coefficient type things. So I use nighttime satellite imagery as a proxy measure of a bunch of things. I also got involved in ecosystem service valuation, which is sort of recognizing that nature has value, and we need land cover information to know what kinds of land surfaces there are, and there are many studies attributing value to ecosystems, and I've used satellite imagery to inform assessments of ecosystem service value throughout the planet. So yeah, it's been a lot of fun. My activity's been a lot of fun.
Yeah, so you certainly are a proponent of using satellites for a whole series of things. So we talked a little bit about at the beginning of our call here about what we're doing at Digital Locations, trying to bring high-speed internet to everyone on Earth, going direct to your mobile phone rather than going through an antenna system or something, external. And so we think that that's a big opportunity for people all over the world to have better coverage. And you started to tick off a bunch of things, from your experience that would help. Can you go through those again? Just run through what you suggested earlier?
Absolutely. If you could get high-speed internet to a satellite on your phone without having to be near a cell phone tower, that if your GPS location did not require triangulation from ground-based cell phone towers, there's many applications, right, that are possible. So people in wilderness areas, hiking, camping, they could send messages and say, I'm lost, I'm hurt, right? They could do those things. They could download maps of where they are, because the cell phone would communicate with the satellite, tell them exactly where they are. They could send them an aerial photograph of where they are. They could probably do even navigation of what's the shortest way to get to help. They could request help. So in terms of wilderness experience, people doing that kind of thing, big plus. But even just regular navigating in your car, I use Google Maps. I think it's the #1 cause of divorce is when the wife is using Google Maps in the car.
The man is trying to using Waze.
Directions. It's just, that and assembling IKEA furniture causes a lot of divorce. And I think that could be dramatically improved if we didn't need cell phones to inform our phone about
towers,
where we are.
You mean cell phone towers?
The cell phone towers, yeah.
Right.
No, you need the cell phone, but you didn't need the cell phone towers to inform your location and either have maps downloaded to your machine or communicate with satellites.
Right. But
So
think about the
that's
greater, think about the wider situation in terms of what you're working on, population studies and the economies and things. Think about all the people on the planet that don't have internet coverage, high-speed data.
This is a great humanitarian potential. I don't know what your profit motive is. This is where we're getting into this domain where technology and the private sector is overtaking government. I think most of the problems in the world right now are a failure of governance, right? So governments have historically conducted a census, right? Which is where they count everybody and they measure where they are and they map them. And the US Census Bureau is engaged in that. And there are issues with trust. But I think the smartest way to conduct a census in the future is going to be with cell phones, right? And there's a lot of government functions like traffic analysis zones where cars are driving on the highway and we have cameras that are set up by the Department of Transportation in every state or federal departments of transportation, and they measure cars traveling on the highway. Google's replaced that because we have cell phones and we know the traffic on the highways at all times. We don't need traffic analysis cameras anymore. But what the problem with that is Google owns that information. How much do they share that information? So I think we're getting a blurring of government things that have historically been government responsibilities that are now through disruptive technology and technology advancement in the private sector is coming to own them, right? And we have misinformation and disinformation coming from Facebook and Google, and who's responsible for that. We have a lot of questions that our society has not caught up with, and we haven't even started talking about AI and ChatGPT.
Right, but to take your point about the work you do with watching the Earth at night and the economic situation you were mentioning, and I see in the papers that you've written about being able to track the economies, by using nighttime satellite observation and the ability for people to then do commerce and have so much more in their lives than they do now by having high-speed internet, and just being able to communicate, to do business with each other, and to improve their lives. So talk a little bit about that based on your experience in tracking these things, gross domestic product, et cetera.
Oh, absolutely. I mean, if you can do this and the price is right, obviously you need to make enough money to be a company. And then there's the question of whether that should be a utility, a government regulated utility or not. But if you can provide that at a cost for the developing world, people in Africa that, are walking to access fresh water, right? But if you can get them high-speed internet on a smartphone, if we can imagine them having smartphones, and they do, right? I mean, even in the developing world, people have cell phones because they're so incredibly, the cost-benefit analysis on getting a cell phone, even for someone very poor, is so high. They get cell phones, right? And you get them high-speed internet and perhaps sort of jump over the whole barriers to access with ISP providers and all that. No, you would do a wonderful humanitarian thing for so many people in terms of their access to information, ability to buy things at the best price. There's myriad philosophical questions about the surveillance state associated with that. We're in the middle of the debate on. I wish Congress would catch up to you, because I think our congressmen are pretty clueless as to what's going on.
That could be true. So talk a little bit about how you are doing what you're doing. In other words, using a night observation to get data on all those things you mentioned. I'm fascinated by that. Can you talk a little bit about exactly how you're assessing things like, business, population, those sorts of things that are not necessarily things you could take a picture of. You could take a picture of a forest fire, but not necessarily of a local economy. How are you doing that analysis?
Sure, I'll try to explain that in
for dumb guys like me.
Accessible way. Yeah, no. In fact, I think that it's important to be able to do that. So I'm glad you're giving me the opportunity to do that. So you see the Earth at night image behind you, right? And you see bright spots and dark spots. And most of us recognize, I think the biggest bright spot behind you is Moscow. Those are urban environments with high population densities. And so the first cut analysis is the brightness of the light coming from the surface of the Earth linearly proportional to the density of population, the people per square kilometer. So that was the first cut on my analysis is the brighter the light, the more people there, right? So a sort of linear relationship between light and population density. And
so let's see if I understand, if I've gotten this so far. Las Vegas.
Yeah.
Enough said.
Yeah. Yeah, exactly. So it turns out it's not perfect, right? There's not a perfect ... along a line that says the brighter the light, the higher the population density. It turns out that the brightly lit areas are urban areas with higher population density. So you can kind of draw a boundary around Moscow and then model population density in a non-linear way within the bounds of that city. And there's a relationship between, and this was discovered by Waldo Tobler, famous geographer, a relationship between how big a city is and the number of people in it. And it's a nonlinear log-log relationship where as the area of a city doubles, the population of the city more than doubles.
I see.
Right? And so you can use that relationship to estimate the population within a blob of light, and then use the brightness of the light within the blob to do a nonlinear relationship with the intra-urban population density. So it's little mathematical games played on the numerical values inside of pixels to estimate population. And then you can do the same kinds of things with...
Go ahead. No,
yeah.
Finish. I'm sorry.
I'm listening. As we go forward, go ahead.
As we go forward, the opportunity for us to know where this high-speed data would be the most effective would be very interesting to kind of mesh our two researches, if you will, our two bodies of research, to know where we might do the most good in terms of bringing high-speed internet to places where there are no cell phone towers and people are in great need of this, where there is population, there isn't a lot of light, there necessarily could be a lot more economic activity if they had access. For instance, if they have water, but they don't have a good water filter to clean that water, the opportunity to order that material and to buy the things they need would be very helpful, it sounds like. Am I on track with that, you think?
Absolutely. I just got a little communication that my internet connection was unstable, so hopefully that will go away. Absolutely. So this is where it's like, is this a public function? Are you providing a public good here? And who do you expect to fund this? Because the benefits would be going to people that may not have the capacity to pay for the technology you're offering, right? And so I don't know about the financing and whether you're going to get money from the Bill and Melinda Gates Foundation or you're going to get from the Goldman Sachs, right?
So we're not
really
in
a question of...
We're not in the operations business. We're strictly a research organization at this point. To do the research to get someone to the point, maybe it's an organization that already owns a satellite constellation. Maybe it's a company that's looking at how to use their constellation more effectively. So we're not looking to go, launch our own rockets and satellites and then do this. We're looking at the research on how we would affect the devices, both satellite and mobile devices, to affect this technology. So we're not in the satellite to mobile communications transmission business as an enterprise, but we're the research arm to try and get the high-speed internet, both on the antennas and the equipment in the satellite, and then on the antennas and the equipment in the cell phones.
Well, I think you're going to want to have this be global, right? I mean, you're going to have global coverage. It's not going to be in a specific location. So you don't have to do the geographic problem solving. I mean, I think one of the big pluses would be internet access in the ocean, people at sea, right? I mean, that's going to be a huge market for what you're talking about. People on sailboats my ship's sinking. And if they radio and, having quick internet access is probably the best way to get help.
Right.
I
And
would
having
imagine.
weather data, real-time weather data and all those things. And we totally agree on that. And so, we're looking to do this as an issue for the public good, as you mentioned, and we're not looking to operate per se. But we think that there's great opportunity, and someone like you who's really studying the world in all its functions and everything from forest fires to economic activity, seems like you can appreciate it, and it sounds like you do in terms of the research we're working on.
Oh, there's no doubt that this would be. I'm surprised it hasn't happened already. I think it probably has happened already for military agencies in various countries. So I wouldn't be surprised if the technology is already there and it's fully implemented exclusively for certain people in certain places. But to make it publicly available, I mean, as I think you're fully aware, this is a profoundly cool thing. It'll be a disruptive thing, and I don't think I appreciate all the implications of its possibilities, but I think I think they're mostly good.
Yeah,
I would like to see that happen.
Hearing that from someone like you really, makes us even more gratified that we're doing what we're doing. So, Paul, thank you so much for being with me today. I'm just really, really enthralled by the stuff you're doing and the study of looking at the Earth at night, especially. And I want to thank you, and I appreciate your time here today. I've been talking with Paul Sutton from University of Denver, and I'm Rich Berliner from Digital Locations. Thank you all for watching.